And here is your note guide video for example number 3 from the projectile motion notes. So you should have already completed this one. And we're just going to go through the answers so that we're all on the same page. As always, as you're working through this, if you have questions, please ask. So Angela throws a suitcase from the top of a 200-foot building at an initial velocity of 30 feet per second. So what's the initial height of this suitcase? Okay, if it was a 20-foot building or 200-foot building, it was 200 feet. Okay, the initial velocity of the suitcase, they tell us, is 30 feet per second. Okay, since we're dealing with feet, we know acceleration is going to be dealing in feet as well. So that is negative 32 feet per second squared. Okay. So then question number 4 wants us to write an equation to represent the height h of t of the suitcase in feet after t seconds. So we have h of t is equal to, again, we always have 1/2 times our a value of negative 32 t squared plus our initial velocity of 30t, or 30 times t, plus our initial height of 200. We simplify what we can, and which is multiplying 1/2 by negative 32. So we get negative 16t squared plus 30t plus 200. So that's the equation that we will be using for questions 5, 6, and 7. Okay. Moving on to the next part. Question 5, what is the height of the suitcase after 4 seconds? So I'm just going to go ahead and rewrite our equation up top. Okay. So if we're trying to find the height of the suitcase after 4 seconds, we're going to plug 4 in for t. So we get h of 4 is equal to negative 16 times 4 squared plus 30 times 4 plus 200. Okay. Plug this into our calculator and we get 64. The unit on this should be feet, as we were trying to find height. Okay. So then it wants to know, when does the suitcase hit the ground? So if we're hitting the ground, our height is 0. So 0 is equal to negative 16 t squared plus 30t plus 200. Okay. To solve for t, we need to use the quadratic formula. So t is equal to negative b, so negative 30, plus or minus the square root of b squared, so of 30 squared, minus 4 times a of negative 16 times c of 200. All divided by 2 times negative 16, or 2 times a. So we simplify what we can. We get negative 30 plus or minus the square root. 30 squared minus 4 times negative 16 times 200 is 13,700. All divided by 2 times negative 16 is negative 32. So we set up two equations, negative 30 plus or minus the square root of 13,700 over negative 32, or sorry, that one should just be plus, and negative 30 minus the square root of 13,700 over negative 32. Okay, we solve our two solutions. And the addition one, we get negative 2.72. And in the subtraction one, we get 4.6. However, as discussed before, we can't have negative time. So we know that it can't be negative 2.72. So the suitcase must hit the ground after 4.6 seconds. Okay. So then question number 7. What is the maximum height of the suitcase? And after how many seconds does the suitcase reach this height? So in order to find the maximum height, we have to find how many seconds it takes first. So we're going to find the axis of symmetry to help us find the vertex, which is the maximum height. So t is equal to negative b over 2a. So b is 30, so negative 30 over 2 times our a of negative 16. So we get negative 30 over negative 32, which is 0.9375. Okay, and again, that's in seconds. Once we have that, we're going to plug that in for t. So h of 0.9375, if you round it, that's okay, is equal to negative 16, my board is messing up, times 0.9375 squared plus 30 times 0.9375 and plus 200. So when you simplify that and get your answer, it should be 214.0625. And again, we were trying to find height, so feet. So after 0.9375 seconds, the suitcase reaches its maximum height of 214.0625 feet. Okay? So again, if you have questions as you were working through these, please ask. Other than that, that is the end of example 2, or example 3.